Welcome to the talk about efficient grid operation with IoT-based solutions. My name is Bruno Opitsch and I'm working as a principal key expert for IoT at Siemens. Since close to 45 years, I'm working in the domain of energy automation applications using RTUs, protection devices and power quality. Today, I want to talk about IoT and cloud solutions and start with a customer statement. Further on, I'm going to show data sources and its use in Grid Diagnostic Suite. The standardized and secure communication and the easy implementation of IoT shall lead us to the use cases and their benefits. To give you a practical feeling about a Grid Diagnostic Suite application, a live demo will complete the presentation. But let us start with the Grid Operators Manager's voice. To learn more about expectations on IoT and cloud applications, we conducted a large number of interviews. Worldwide, the top response was, we need to increase grid operation efficiency by getting more transparency on overloads, extreme operational conditions to prevent outages, and in case of a fault, precise information as fast as possible directly to the team to tackle them. So the question is, how do we get those data from the process to the people which have a need of? Shall we install thousands of sensors as on the Internet of Energy? Or do we have an alternative in our digital substations? And yes, we do. Because in energy automation, we use digital devices since years. But at a closer look, it turns out that only 5% of the available data is used for grid control, and the additional data for maintenance or grid planning remains unused. How to access without overloading control center? The answer is using the cloud and the powerful data handling there. In addition, in the cloud, we can correlate with external data as we did already in some of our projects. As one example, to predict damages on medium voltage distribution poles, we use data of snow level, flooding, bird population. Result? We could reduce incidents by 90% and saved a lot of maintenance budget. There are a lot of off-the-shelf applications available, which are designed to run on cloud environment, like on MindSphere operated by Siemens. How this works, we will touch during the course of the presentation. For energy automation, off-the-shelf, ready-to-use applications are available under the umbrella of the Grid Diagnostic Suite. These applications are cProtect Dashboard, CCAM Navigator, CCAM Localizer, Power Quality Advisor Premium. Their focus is on grid assets transparency, to understand the utilization of the power system and to enhance thereby efficient grid operation and quality of service. As mentioned, the four members of the Grid Diagnostic Suite are the cProtect Dashboard, using protection data to show operational status and advanced data like fault records. The CCAM Navigator and CCAM Localizer showing operational status of distribution grids, while CCAM Navigator is focusing on underground cables and CCAM Localizer on overhead lines. The fourth application, the Power Quality Advisor Premium, helps to avoid non-performance costs because of harmonics, power factor problems or brownouts. Let's have a look on the concept and technical realization. On top of the diagram are the applications running on a PC or mobile device, so that all necessary process data are available, independent from where you are. These applications can be off-the-shelf applications as Grid Diagnostic Suite or your own apps or apps of any third-party supplier. This is made possible by MindSphere, our cloud-based open IoT operation system from Siemens. And on the bottom of the diagram, representatives are shown of all the typical devices we are using in the energy automation domain. For Siemens, we can name CCAM A8000, cProtect 4 and 5, and Rayroll devices. But a new world is also open for other brands. Anyway, very important is the communication in an IoT concept. Having a look into various studies about experience with IoT pilot projects, the majority of those which failed struggled on communication and the number of devices to be onboarded and engineered. This shouldn't happen in our domain because of a comprehensive approach. Having a look to the IoT world, the international standard available in all cloud systems worldwide is the IEC 62451, better known as OPC-UA, Open Process Communication Unified Architecture. This standard defines how data are exchanged and the cybersecurity controls to be compliant with. In our domain, the international standard IEC 61850 is well accepted and clearly defines the data modeling and services in use. So the ideal formula for IoT for energy guarantees in the connectivity in the IoT world and interoperability in the energy world, with a clear defined data structure and thereby assures no vendor lock. Having a look on the internet page of IEC or OPC Foundation, the promotion of combining both standards is vice versa. By the way, the combination of OPC-UA and 61850 also tackles data handling issues and allows a fast, easy and secure automated onboarding. This means automated onboarding with no human interaction saves time, and due to the minimum of cloud engineering, a lot of money as well. As an example, effortless engineering in the cloud avoids typing faults or wrong mapping and reduces therefore the test effort. And protection of data and assets is based on secure communication with encryption algorithms and authentication of communication partners. And all works with an as simple as possible engineering process. What we have to know and to handle are 3 certificates to make sure we are connected to whom we really want to talk to. There is our own root certificate, which is the digital ID card of our company or project. Let's call it utility number 1. From this ID, we derive a certificate to identify a device belonging to the utility number 1. Installing the public part of our ID into the cloud and the device certificate on the device prepares the partners to pair. While doing so, we install the public certificate of the MindSphere in our device to verify the cloud identity in the next step. Connecting cloud and device physically, device and cloud will encrypt the communication and authenticate each other. Due to that procedure, MindSphere knows to which tenant the data must be routed and creates there the database according to IEC 61850 within minutes. This sounds all very nice, but how do we get physical access to my data, especially in existing substations? Just add an CCAM grid edge device to your IEC 61850 substation bus without changing settings in the existing system running. The only configuration necessary, beside cloud address and certificates, is the IP range of our protection relays. CCAM Grid Edge will now get all data and put it into the data container of OPC-UA and send it to the cloud. This separate communication channels leave the secure configuration of the control center connection untouched, but enables new ways of working to facilitate efficient grid operation in various perspectives. Today's improvement shall handle delayed fault information and missing location information, which makes it necessary to patrol the lines and identify fault location and root cause. With a notification, Grid Diagnostic Suite draws the attention immediately to the necessary information of the present situation. As example, CProtect dashboard shows the affected substation and relay tripped, or the CCAM localizer shows the overhead line section affected by highlighting the fault locator position. Up to now, missing transparency on secondary and primary equipment was handled by a time-based maintenance. But even though sometimes unplanned outages being caused by failing station equipment or environmental incidents causing malfunctions. Just a simple example, the CCAM Navigator can notify on various incidents like water level rising in secondary substations, or the CProtect dashboard shows the firmware of substation components to verify cybersecurity compliance and thereby identify necessary updates or patching. These and many more information will help to improve risk management and optimize maintenance planning and thereby leverage the crew capacity. Even better than a swift fault handling is to avoid faults. Providing information of stress on power grid equipment or simply real-world load profiles are increasing efficient grid operation and planning. Examples for that are CCAM localizer showing fault-prone zones due to isolators or vegetation problems, or load profiles of low voltage distribution to check if the grid is able to handle future challenges like e-cars or rooftop-mounted solar panels. If you like, you can experience the new work style in an online demo. Just use the link in the handout or go to siemens.com/IoT-energy-automation. To summarize, the Grid Diagnostic Suite with its applications, CPROTEC Dashboard, CCAM Navigator, CCAM Localizer and Power Quality Advisor Premium will help to reduce operational costs by preventing outages, reducing operational costs, affecting fault handling and prevention, and improve grid profitability, as well fulfill regulatory requirements, reducing SAIDI and SAIFI. I hope I could give you a brief insight how IoT can help to increase efficiency of grid operation. Thank you very much.